It does seem intuitive that you should plan for a more resilient system, but why do we not do it? If we're doing the wrong things the right way, that doesn't help us too much. And if we're doing the right things the wrong way, then we're also missing something. So everybody knows this feeling of regret, but there's a way that we can quantify that mathematically in decision making as well. As a society, one of the aims is how do we talk about the concept of sufficiency? How do we normalize the discussion and not make it a scary word? What we want to do is see how we can learn, unlearn, and relearn. And that's very important for us to be able to tackle the entire climate crisis.
That is Mashael Yazdanie, group leader, scientist, and lecturer at the Urban Energy Systems Lab at the Swiss Federal Institute of Materials Science and Technology, Empa. Having gained invaluable experience in the engineering and planning aspects of practically every form of renewable energy, Mashael has made it her mission to understand more holistically how we can design energy systems for better resilience, sustainability, and sufficiency. Her work has spanned both the global north and south and has not shied away from embracing the complexities of decision-making under climate and societal uncertainties. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Mashael and I trace her journey in amassing her experience in the renewable sector, from biogas in Pakistan to solar, wind, and tidal energy across Europe, Canada, and Ghana. We discuss the intricate balance that future planning has to strike between the fine lines of planetary boundaries, well-being, and equity, the difference between efficiency and sufficiency thinking, and how to minimize regret in future planning. Detailed information is provided in the show notes over at peterandbach.com/podcast. Thank you for joining us today, and please enjoy the show. Mashael, welcome to the show.
Thank you very much.
I'm looking forward to getting into renewable energy. I'm not an energy guy, but it's always been in the back of my head every time I've been reading about it or researching about water-related aspects. We can't forget about energy. So very glad that we met and that we could do this show today.
Yeah, thank you for inviting me to this show. It's it's an honor and a privilege for me to be able to be here. So thanks a lot.
Likewise. And what better way to start with the energy topic than with a very quirky hobby that you did, which is solar race car driving. I thought that was such a perfect combination of, I guess, doing something, thrilling, but at the same time staying within the renewable energy sector. So could you tell me a bit about that?
Yeah, sure. So that I would say was my first exposure or experience with dabbling in the renewable energy field. And it was during my bachelor's at the University of Waterloo, where I was studying engineering, so systems design engineering. And so I joined the solar race car team as a machinist and a solar race car driver. So the solar race cars, I don't know if you've ever seen one, but they're quite flat and small, and you're trying to make it very aerodynamic. So it's a small space. And so often the drivers were female because I was small or short. I fit in well. It was a hot, uncomfortable environment. So I joined, as both a mechanical engineering team and as the race car driver. Yeah, so we actually, an interesting fact there is that we set a world record at the time.
Oh, wow.
For the longest distance driven by a solar race car. I think it was in the order of 15,000 kilometers. And this
15,000?
Yeah, 15,000.
Oh my God.
And that was a trip around Canada and the United States. And so I joined the team for not all of that, but for part of it. And so, we were successful in setting a record. I don't know when. I'm sure it's been broken since then. I'm not sure where it stands at the moment, but it was quite a nice experience and an interesting one too, in that not many people had seen a solar race car at that time. So this was 2006. I think, or was it earlier? I should double check the date. But people didn't have much exposure to it. So there was actually a couple of calls to local radio stations about a UFO that was driving on the highway because it really looks like a UFO. So that was, an interesting experience. And got me first exposed to solar energy and was something that, really was a hands-on project. And so I learned a lot doing it, and it was my first experience with renewables.
I think I've seen pictures of solar race cars before, and they really have this extremely flat thing, a flat piece to host all the solar panels on it, right? And then you have the aerodynamic aspect. So not exactly, as you said, the most aerodynamic car, but 15,000 kilometers. I mean, did you do it on a single charge, or like you basically run it throughout the day and hope that you have enough energy for the night, or how does it work?
Yeah, it was basically, it was over several months, I think, even it was over the summer. But you would drive all day as far as you could go, and then you would have a stop. You would try to plan them. We stayed in all sorts of interesting places. We slept in parking lots of Walmarts, which at least at that time had a policy that you could sleep in the parking lot of Walmart. We slept in churches. We got a lot of people who were donors or opened their space, or farmhouses. And so all kinds of, it connected you with the communities all around. Driving in the rural United States. I was there mostly, I think it was in Kansas that I was part of the the route there.
Did you ever go past Area 51? At some point?
Probably. I wasn't there for that part, but that's maybe probably where we got the UFO calls. I can imagine.
I was watching a documentary, I think it was just a few days ago, about UFOs. And I think 2007 was one of those years where everyone went crazy because I think the US government declassified some documents about them. But either way, it's a funny anecdote that you can share as your first venture into renewables. I guess you call these chance encounters. One chance encounter was how we first met. You were interested in the topic of nature-based solutions, and I so happened to be in the topic of NBS alongside a guest that we previously had on the show, Martijn Kuller, all the way back from episode 3, and you reached out to both of us. So renewables and NBS, where do you see that connection?
Yeah, that's a great question. So I didn't know much about nature-based solutions, or NBS. And I had come across a paper which was by Pan et al. There's several authors there. And I was fascinated by the paper in that they did kind of a meta-analysis with several cities, I think more than 50 cities around the world. And they had found that if you considered nature-based solutions for climate mitigation and not just climate adaptation for cities, that you could reduce emissions potentially very significantly. I think in some areas up to 20% or so, if I remember correctly. And so that paper really got me thinking that there's something missing in how we're tackling the problem. If there's such a massive potential for nature-based solutions to mitigate emissions in cities, why are we only looking at it from mainly a technology and efficiency perspective in cities? And how do we integrate renewables, and how do we make buildings more efficient, which is all well and good. It's very important. But we are missing potentially a massive solution there, which would be nature-based solutions. So I didn't have much experience with it, but I see that it's a beautiful way to connect both climate adaptation and mitigation in a city, and brings a lot of co-benefits, synergetic benefits in terms of you have a greener community, you have more energy efficient buildings, you have more resilience in a city. For example, when you have these green sidewalks or pavements, that you have more resilience to flooding or drainage.
Something that would be my angle, which is interesting because when I think of the energy side in NBS, the limit that I've hit, and that's where I lack the knowledge, and it makes this bridge so perfect, is, we think of heat mitigation in cities, and that's where NBS can actually help reduce building energy demand and at the same time mitigate heat indoor, outdoor because of the insulation effect of vegetation, and that in itself has a knock-on effect to reducing emissions, which is, I guess, clearly at the forefront of your mind. Whereas for me, it's usually about water quantity in cities, or keeping it in the cities, whether it's too much water or too little water. But we have to somehow balance this across every kind of sector. So definitely very interesting connection that we made there.
Yeah, absolutely. I think that's speaks to the synergetic benefits, actually. So there's so many different research areas, well-being areas in the city that nature-based solutions can help with. And so I think that's, to me, in my current thinking as a researcher, the types of solutions that I would like to focus on, that I think have the best chance of succeeding, are those that have multiple interactions and co-benefits across different systems. So yeah, you're right. The water management can be a huge part of it, urban biodiversity, even sustainable food, urban farming. From the energy point of view is, of course, where my, initial interest is as well, is how do you make buildings, they're better insulated in the winter, so you need less heat, and they're also cooler in the summer. So you mitigate urban heat islands, and you also keep well-being of vulnerable populations in mind in cities. So there's so many ways that it benefits cities or communities. So that was my initial interest there.
No, definitely. And that was not always what you were pursuing. You were more focused in the early career on the technical aspects and really about optimizing energy systems, in particular, all the different renewables we have at our disposal. But our chance encounter was just one event, but there was an even bigger one that came before that, which changed your mindset completely. And that was a key conference that you attended. Could you tell me a bit about that event?
Yeah, absolutely. So I think in the last couple of years, there's been a couple of key pivotal moments where I met very interesting people who are outside my field who presented me with new ways of thinking, new ideas that I realized I had not either been exposed to at all, or they were new to me, or I had just vaguely heard about them, but not really thought about them. And so one of these pivotal moments was at a conference in Switzerland, actually a local conference called CISPAT. And there they had a keynote speaker who spoke about the concept of sufficiency. Mm-hmm. Her name is Dr. Yamina Saheb, and she's a policy expert. She's a lecturer at Sciences Po and an IPCC lead author. And through that talk, I realized that I was not very familiar with the concept of sufficiency. And it was something I had this kind of epiphany moment that there's something that I've really been missing my whole career, actually, and in my education as an engineer, somebody who's working in the energy field for a long time. And I wasn't really sure, is this my fault, or is this something that I have missed? But
I can totally relate to these kinds of moments because I have been to certain types of conferences, usually the ones that are outside of my field. I'm thinking about diversity one, as well as, I guess, one of my first events that I attended in Switzerland. And that was when I also, sometimes you listen to a keynote and you start seeing these concepts you've never heard of. And all of a sudden they open a whole, I guess, train of thought in you and you start to get obsessed with it. And I guess in your case, it's this sufficiency concept, which we will definitely, I think, see pop up a few more times in our discussion today, but also underpinned by two other terms, which have popped up for me and which I think would be very nice to get into for our listeners. So we got the sufficiency on the one hand, but we've also got this concept of planetary boundaries, as well as this idea of Doughnut economics, which relates a lot to equity and well-being. Where would you like to start, perhaps, in shedding some light on these concepts?
Yeah, sufficiency, I think you put it very well, that it opened up a whole new train of thought and led me to many other concepts. And so it is something that I'm trying to shape my research towards right now, because I have this feeling that it's something that can really help us in tackling the climate crisis. And so what sufficiency is, it's defined in the IPCC report, and this definition developed by also Dr. Saheb is that sufficiency is a set of daily practices, measures, policies that we put in place which avoid our demand for resources. And those can include energy, land, water, all types of resources. And there's two key aspects to that is that we want to reduce our demand while maintaining well-being for all people and staying within planetary boundaries. Okay. And so fundamentally, sufficiency is about equity. And so this is, I think, quite a unique perspective compared to technocratic approaches.
And this is different from efficiency, because we often talk about trying to be efficient about things. We're not, I guess, running our air conditioners too long, for example. We want to make sure they use just the right amount of power or less power. I mean, is that different to sufficiency, this idea of efficiency?
Very much so. And I think they're often, maybe because they rhyme, I don't know, but people often link them kind of together. And they're both important, but they're quite different. So when we talk about renewable energy and efficiency, we're talking about a way of doing things the right way. So we want to make sure that if we need energy, we want to make sure that it's renewable based. We want to make sure that it's from sustainable sources. And with efficiency, we want to make sure that our air conditioners are efficient, our heat pumps, our heat sources are efficient. And so I see efficiency as really about doing things the right way, whereas sufficiency takes a step back and comes before renewable energy planning and efficiency. It's kind of your starting point, and it's about doing the right things in the first place. So together, sufficiency is somehow about let's do the right things and let's do them then the right way, which is where renewable energy and efficiency and different, circular economy thoughts, they come in because they're both important. But if we're doing the wrong things the right way, that doesn't help us too much. And if we're doing the right things the wrong way, then we're also missing something. So that's why they're two sides of maybe the same coin.
Okay, so yeah, it's a bit of the right and the wrong way, and you're trying to find the right way, doing the right things in the right way, I guess at the right time.
Yeah.
Oh, I'm still trying to get this around my head. But I guess looking at the planetary boundaries, this helps us understand this concept a bit more. So planetary boundaries, concept that the Stockholm Resilience Center actually brought out roughly around the same time I actually arrived in Switzerland. But basically characterizes our planet as having these 9 critical processes, and some of them we have kind of exceeded and overused and overextended, and others we're kind of doing okay, or we have no clue whether we are because we're just unable to measure it. And I know there's this famous graphic which keeps changing over the years because we keep track of what's happening. But these 9 critical processes, they include things like climate change, the stratospheric ozone depletion, atmospheric aerosol loading, novel entities, apparently something we can't quantify yet, the acidification of oceans, biogeochemical flows, freshwater usage, land use change, and the integrity of the biosphere, so the biodiversity-related aspects, flora, fauna, and the ecosystem. I mean, that's a very holistic way of looking at things. And I guess sufficiency comes into play because we're trying to make sure we don't overextend and that we use things in a more sustainable way.
Exactly. Yeah. We want to make sure that we both meet our needs as human beings and meet everybody's needs. So everyone's well-being is at the heart of it, and also the planet's well-being. So it's really, when you think about well-being, it's not just us, but it's planetary well-being. And so that's where planetary boundaries come in. So we want to make sure we stay within planetary boundaries, yet meet everybody's needs. And yeah, with the planetary boundaries, if I may just add one comment there, from the 9 planetary boundaries, we've exceeded 6 of them.
No, not doing too well.
Yeah, we're doing quite badly. And I think the only ones that we are doing well on is ozone depletion. So that's the only one where we're okay. But ocean acidification and the aerosol loading are starting to approach their boundaries also. So it's quite scary because we've just, passed the 6th and the 7th and the 8th are not far off.
Yeah, and I guess for some of the others where, I guess we're doing sort of okay, it's also because we're not really able to measure the level of overexceedance yet.
Yeah, maybe. I wouldn't be an expert in this topic, but related to novel entities, for example, I think we have no idea, what influence the materials, the chemicals that we're introducing into the environment, what the long-term effects are going to be, how to measure these ecosystem impacts and interactions. So I think there's a lot unknown, which means that given how little we know about what we're doing with these planetary boundaries, but we get this idea, this picture that we're clearly violating a lot of them, we're not on the right track. That should give us pause for thought, and especially that the unknowns should humble us in our approach there.
That is true. And really, this framework is around understanding or setting a limit for the planet's own functioning, beyond which the planet is unable to repair itself or to regenerate itself. They say nature is quite resilient, but if you mess with Mother Nature, then at some point, even the planet can't save us.
Yeah, exactly.
Yeah. Then we have the other concept, which I really like it because of the name. But maybe shed some light on Doughnut economics. And this relates to the well-being and equity aspect.
Yes, definitely. So the Doughnut economic framework was developed by an economist at the University of Oxford. Her name is Kate Raworth. And it was in the early 2010s that she developed this framework. And it really also is at its heart also about equity and well-being and planetary boundaries, and therefore also gives you a framework to think about sufficiency. And basically, if you imagine a donut, it's a nice visual. So if you imagine a donut, on the outside of the donut would be your planetary boundaries. So the 9 planetary boundaries that you mentioned.
Do not exceed these.
Do not exceed those, exactly.
Do not exceed.
Good one.
I just had to, sorry.
That's a good one. And on the inside are your pillars of your social foundation, your social needs. So we can also talk about that as there's, this kind of human development needs and what we need to do well as human beings.
So things like water, food, health, education. So, both the physical, but also the mental self-developmental needs.
Exactly. Yeah. Also, equality, gender equality, justice, all of these kind of concepts. And so those are in the inner part of your donut. And so in the donut economic thinking, if you imagine the actual space of the donut, that is between outer thresholds of the planetary boundaries and meeting the social needs. And so that's what they call safe and just space for humanity. because it's the only place where both the planet and we can thrive. And that is also a sufficiency space, actually. So what is sufficient to meet our needs? And how do we stay within the planetary boundaries?
So simply remaining within the donut itself.
Yeah.
The most delicious part. Because then life is delicious.
Exactly. The tasty part is
I do like the analogy of it. And it's really catchy. When you mentioned it to me the first time, I remember the book that Kate Raworth wrote that I saw in the bookshelves in the bookshop. And I always thought, this is interesting. I never actually picked it up, but now I think after this discussion, I'm going to have to go order myself a copy and have a read of it, because I think as a concept, it's very powerful. I think to illustrate how we might shape society to be sustainable in the long run. Yeah. So, these concepts, and thank you for a nice 101 on that. I think it's enlightened me as well. But they really are what underpin your current research, your current work, your current mission to try and create, a better world. But that came from your initial techno-optimistic or techno-centric view of the world, the early days of your journey into renewables. So we mentioned the solar race car. You said University of Waterloo. That's where you got your bachelor's in applied science, system design and engineering in 2007. Tell me a bit about the path that you took. And you've mentioned solar, but there are a few other renewable energies that you've worked with, right? What shaped you in pursuing that in the first place? And I guess what else came after the solar race car?
Yeah, great question. So going back, it was a long time ago. After basically as an engineer, I was trying to find meaning in where can I contribute to society, because I liked applied math. So I went to engineering because I wanted to both be involved in mathematics and physics, but do something useful and applied for the world. And so I thought engineering is the sweet spot there. And initially I was quite into robotics in engineering. And that was, I think if I maybe could have chosen anything, I would have stuck with robotics and building the Canada arm and, doing these cool kind of projects. But then I thought at one point it dawned on me that I think what the world needs more is sustainable energy, given the climate crisis that we are in. And I thought, how can I make myself useful in that space? And I had the exposure to solar energy through the race car project. And my next kind of exploration was with biogas energy. Uh-huh. So I'm also Pakistani. So I'm Pakistani, Canadian, and Swiss.
Wow.
Yeah. And that's been a blessing in many ways. And so I felt very connected to Pakistan. I still have family that's in Pakistan. And there was an earthquake that happened, I believe it was 2005. There was a massive earthquake in the northern areas in Pakistan, in Kashmir. Mm-hmm. Muzaffarabad was where it was the epicenter of that earthquake. And you could feel that earthquake. I think it was 7.6 on the Richter scale. You could feel it all the way to China, Afghanistan, Tajikistan, India. So it caused massive damage. There was a lot of deaths. And in several areas that were quite poor also. And so I found an opportunity to work as a volunteer, as an engineer on energy challenges in an earthquake-affected region in Kashmir. And I worked then with an NGO, but the experience was really, life-changing in some ways. The NGO basically dropped me off as the only volunteer in a village. Luckily, I can speak Urdu. So not very well. So it was a good, because there's no English there. But the NGO was like, okay, you're an engineer who knows about energy stuff a little bit. So we'll leave you in this village and make yourself at home and see what you can do.
Oh boy.
So that's
really, a lot of trust.
Yeah. So they really just dropped off. I don't know how old I was. It was 21, I think, or something like that, early 20s.
And you had just finished your bachelor's, right?
It was in my bachelor's, actually.
I believe it was your final project or your thesis.
One of them, exactly. Yeah. So at Waterloo, they have these 6 co-op terms. So basically, I had it as a co-op term where we work and we go to school, we work and we go to school. And nice. So at the end, it's quite good because your bachelor's takes longer. It takes 5 years, but you end up with 2 years of work experience. So this was one of my terms. I decided to do this volunteer project. And it was interesting because I didn't even know what I'm going to do. They had energy challenges there. They relied on biomass for cooking fuel and for their energy needs. And a lot of that with landslides had been lost. It was already problematic because it was illegal deforestation. So they didn't have a good energy solution to begin with. And the earthquake had made it so much worse. They had lost their homes and their livelihoods.
So to bring in some context, I guess you had this earthquake that struck. And so these kinds of disasters will often cut cities or villages or towns off the energy grid, off secure water supply. And in a way, this project was also you bringing in some kind of better resilience to the particular rural town that you were dropped off in. And I believe it was also in the middle of winter, or was it around that time?
It was luckily in the summer.
Oh, luckily in the summer.
I think it was the summer, yeah. And I'm grateful for that because winter would have been harder. I lived in a refugee tent with the family that I was staying with, and they didn't have running water. So we used to go collect water. So I went with the women. It was a nice bonding experience, actually, because I worked on my Urdu. I learned from them, and we went to collect water. We didn't have electricity often. So you had intermittent power in the village, but it was very intermittent. So whenever you got a chance, you charged up your phone, and also for even basic things like taking a shower. You would have to go to the bathroom. I went to a bathroom with a stick because there was wild dogs in the area.
Oh, jeez.
It was interesting. It was really a great experience and a humbling experience. Yeah.
An adventure. Definitely something that you felt would, really, it's definitely a very noble mission as well. And to be able to couple it with your studies, I think really made a big difference, because in the end, it was about this biogas plant. And you tried to optimize it ahead of time or while you were there with some modeling that you were doing. So you coupled the modeling with the on-the-ground experience.
Yeah, actually, the modeling came after, because when I got dropped off in this village, I didn't know what I was going to do. And so the first part of my stay there was just trying to figure out what kind of energy solution might work here. Would it be PV? What would be helpful, and what would be affordable? And there were so many things to think about. And so I spent actually the first good part of it just talking to people in the village, interviewing people formally in the village. There were some architecture students who were also volunteering there. So we worked together to try to interview people. And I don't know how exactly the idea came to my mind, but because they had a lot of agriculture, they had cows, it kind of occurred to me that I didn't know much about biogas, but I thought, okay, maybe biogas digesters could be a good solution to look at. So I went back to the city where I also still had some family and I could stay with, and I did some research. I talked to some people also in the government. So I worked with the PCRET, it was called at the time, which is the Pakistani Council for Renewable Energy Technology. And I was like, look, what about if we introduce biogas into rural areas, because they already have cow manure and they use it for fertilizer. So they already use it as a resource. But if we can install a biogas digester, it can help meet their energy needs, so for cooking and for lighting.
Secure supply chain.
Yeah, and again, it was one of these, this is the recurring theme in the topics I'm excited about, was one of these synergetic kind of solutions, because it offered many co-benefits. So not only when you put manure, it's a very simple construction, just to imagine what it is. It's basically a big hole in the ground, like a 10-meter deep hole. And basically the most expensive part of it is a steel drum that's just sealed. So it's a hermetically sealed steel drum. And with the manure that gets filled in the hole, there's basically, you put the manure in, it reaches the bottom, and then you fill it from the bottom to the top. So the manure at the top is the oldest, and that's your digestate that comes out.
Okay.
And the drum is what gives you the pressure. So you just put the drum, it's basically like a cap. So you just put the cap in the hole, submerged in the manure slurry mixture. And from the pressure of the weight of the drum, you just have a valve at the top and you run a pipe through it, and you can run that to your stove or your lantern.
Interesting.
So that's basically the construction of it is quite simple. And the beauty of it was that the manure that came out as digestate was actually better fertilizer than what they normally did, which was just let it air dry and then they used it. It was richer in ammonium, actually, when it comes out through this digestion process. So that was one nice co-benefit.
This is music to my ears. I mean, I'm always, striving for multifunctionality in the blue-green infrastructures or nature-based solutions that I work with. Maybe I should go into renewables, because you have there's no one-size-fits-all solution. You identified it based on local context. Then, you have the circular economy, or I guess the multifunctionality and circular economy, and, waste becomes resource. And throw in I don't know if you want to call it that, but economics. Probably not. It's probably not that, but I'm trying to remember where I remember seeing that word. Probably was some internet meme, but either way, very interesting project. And I guess one of those cases where you could really get on the ground and see how the social aspects factor into the design of a renewable energy system, and that it's really more than just the technological aspects.
Yeah, absolutely. I think that's also with the co-benefits that I was thinking about. Indoor air pollution because of burning biomass indoors was actually a big problem for us, particularly women and children who spent a lot of their time indoors or doing the cooking. And so with biogas, actually, it burns clean. So it was better for health. For indoor air pollution, it also reduced stress on deforestation because of this illegal logging that was happening. And one of these biomass digesters would support like a family, I think, of about 10 people for their cooking and their lighting needs. And also waste management. You could also use, scraps from the kitchen. You could use human waste, but that culturally was just not something that was normalized, but you could also. And also it was a grassroots initiative. So we worked with local masons and steel workers to create it. So the idea was that they would be trained. And so it creates also local jobs, and hopefully it was a pilot project with the hopes then that it would take off after that. And so, so it met a lot of different needs, socioeconomic needs, technical needs, energy needs. So
a true marvel of systems thinking, definitely. Because without systems thinking, I think you wouldn't be able to call it optimize it as well as you did. You relying on the local labor, creating the local jobs, and just seeing all these additional benefits from just choosing the right technology in the first place.
Yeah.
So what else have you collected? You got the biogas, you got the solar, but I know you've also worked in wind.
Yes. So after that, in my last co-op term, I actually worked with a startup wind energy company in Canada, in Western Canada. So it was in Alberta. And so it was a startup because at that time, there was not a lot of renewable energy. Alberta's kind of an oil and gas haven. So it was, it was a pretty new area. And so it was interesting to work with the wind energy startup. And after I graduated, I continued working with them as a project engineer. Where I was working mostly in the context of Alberta and British Columbia, also a little bit in Saskatchewan, to figure out where it would be good to place wind energy projects. It was a lot of multi-criteria decision analysis, field work also. And that was an interesting experience in industry.
What were some of the more interesting criteria you had to consider when you're deciding on where to place wind turbines?
Yeah, it's been a long time now. But there was, of course, the wind energy modeling. So we worked with the mesoscale wind modelers because, of course, the first criteria is you need to have good wind resource. But that's not sufficient. There was considerations of what the current land use is. Mm-hmm. So what permissions you would need, if farmers would be willing to work with you. So we went talking to farmers actually door to door, even when there was a project that would be potentially viable on their property. There was the distance to roads, so access on how expensive it's going to be to build this project, distance to power lines. Doing the power grid. So we had some consultants, if I remember correctly, who helped us with the wind energy modeling and with power grid kind of assessment of where there's capacity to link up. So there was other restrictions. So if, I don't know, for example, if it was in a naturally protected area, that we wouldn't be able to do it. There was a lot of different factors, but I remember that these were kind of really key ones is wind resource, distance to roads, distance to power lines, capacity, grid capacity, and land use, potential conflicts. And so then you kind of, through this process, you identified areas with more potential, also how large the site would be. And so all of these came into also the technical and financial feasibility and viability of the project.
What about noise and aesthetics? Was that ever in question?
I remember I went to a couple of conferences where this was often a topic, this NIMBY, not in my backyard kind of problem. So definitely that was a concern. And so there would also be farmers and people who wouldn't want that on their property, but also sometimes a curiosity and a way for them to profit basically off having renewables there, because they could still, also one of these synergetic things is that they still use their land for agricultural purposes, but they had a relatively small footprint turbines on their property. And so if they didn't mind that, then it was another income source. So there was kind of mixed reactions to it, definitely.
I mean, the two landscapes I picture when I think wind turbines is driving across Germany. So on the Autobahn, you see in the distance all the wind turbines, quite a few of them bunched up. And then the other experience I had was when I holidayed in Gran Canaria, which apparently you see a lot of them out in the ocean, and I think on the shores as well. I think that island has a lot of reliance on wind power as well. So very interesting. I know it's always been a big debate in, I think, Australia. There was some debates there about it, especially about the noise and the looks. The NIMBY is very much prevalent, not just for wind energy, but for many other things too. So something I guess very challenging, because wind alongside solar, I guess, they're often in your face. They are very conspicuous. Well, maybe solar can be quite inconspicuous nowadays. You put it on your roof, but wind has to kind of reach out for where the wind actually is. So wind, solar, biogas. I think you also worked with Tidal at some point, or you had exposure to tidal energy. Yeah.
So after my wind experience, so the 2008 economic crisis had hit, and the wind energy company didn't last much longer. And so I was basically looking for a new, it was a good time to basically go back to school. I was always in my mind kind of between industry and research. I had never picked one kind of allegiance. So I liked, I liked research and development when I worked in robotics context. So I knew I liked the research context. But I wanted to do something in renewable energy. So I worked in wind energy. And then when I was basically then between jobs, I thought this is a good time to go back to school. And so I came to Switzerland just out of curiosity because renewables in Europe was far more advanced than it was in North America. And so I just thought it would be nice to be exposed to renewables in this environment and learn what I could. So I came for my master's, and then as part of that, I did 1 year in Munich at GE Global Research at the time. I had a global research center in Munich. Although I was based in Zurich for the first year, the second year I spent at GE doing my master's thesis and
deciding on your allegiance.
Picking. And again, it was R&D, so I was really excited
True.
because it was research and development, but now in a renewables context. So for me, that was kind of a really nice sweet spot. So while I was at GE Global Research, I worked on 2 interesting projects, which were solar energy and tidal energy. And GE, because they were making wind turbines, they wanted to see what the applications could be underwater. So I did some modeling for tidal turbines and in my master's thesis, solar PV. And the solar PV parts were about how can we maximize the efficiency of plants through minimizing losses, mismatch losses of when they had variations in production, of how you bin these modules after production so that when you hook them up, you have less losses. And so my thesis was about that. And actually what emerged from that was a binning process that would help significantly improve the efficiency of the operation of the plant. So that was where I dabbled in solar energy. And after ETH, I went on to doing some research in life cycle analysis for sustainable mobility. So looking at the passenger vehicle fleet and how it evolves over time. In the Swiss case, looking at the sustainability of different drivetrains, whether they were fuel cell vehicles, electric vehicles, plug-in hybrids, all of a comparison basically.
So all the different fuel cells and ways to power the vehicles as well. Wow. So collecting even more, not just types of renewable energies, but also applications of them, especially in, I guess, the big energy uses as well. And in a way, your time at ETH, and I believe also the Paul Scherrer Institute, one of the research institutes within the ETH domain, was spent not just on specific types of renewable energies, but also this idea of decentralization. I guess before we go into that, so after touching upon all these different topics, do you have a particular favorite renewable energy?
I wonder. I mean, I'm a systems thinker, and I try to think about problems in this whole holistic way as best as I can. And so I think what emerges from that is there is no one clear winner to me. I mean, it's a system, as you've mentioned as well, in the biogas case, it was very contextual that biogas made sense for this community. So if you put me in that context, I would say my favorite is biogas, because of the co-benefits you had. And for that community, it was really a great solution, but that may not work elsewhere, So at the end, you have kind of this medley or this mix of technologies that's needed. I think if I were to build a house today, I think definitely heat pumps for my heating system would be a top pick. PV panels on my rooftop, if possible. Those would be kind of the 2 things that personally I would vouch for. And often from these optimization models, you always get the answer of we need heat pumps. We have to switch from fossil fuels to heat pumps. It makes sense from a cost point of view and environmental point of view. So that's always kind of a winning technology. So maybe I have a sweet spot for that. But
I mean, as long as you do it correctly, you're allowed to have a pet favorite. I mean, I tend to have pet favorites as well in my own field, but we'll save that for another episode or maybe for one of these special episodes. Listeners, you can tell me if you're interested in knowing. But either way, as you've rightfully said, different renewables for different contexts, and in particular, it's not a rigid centralized system. You have the grid, and I believe from my limited experience, you can put in any excess energy you generate back into the grid. So that sort of serves as, call it the big supply hub and transfer hub of electricity or energy in general. But decentralization, I mean, I know decentralization in the water context, then we often think about harnessing different water supply sources, whether it's rainwater or wastewater. But in terms of energy, you've got the centralized grid, which is always there for a certain resilience, I guess. But what are some of the key, things we should be aware of when we think about renewables and decentralization?
Yeah, so in my PhD, this was actually, the topic was decentralized technologies. And I looked at it in the Swiss context, basically looking at different types of communities in Switzerland. to get an understanding of how important a role local energy resources played for these communities and which technologies would come in. And as I mentioned, PV and heat pumps, for example, were a big part of the heating and local generation mix, but there was also small hydro, there was local CHP, district heating. So we looked at everything and we saw different patterns emerging in the Swiss context for different types of communities. And so in the south, you might have more PV. In big cities, you would have a different mix of technologies. You'd have less small hydro. In rural areas, you have the hydro come in, so different wood levels of biomass come in as well. So you see different patterns and you really see that context emerging, that there was no one right answer, but it really depended on the community, the location, the type of resources they had access to, also the type of energy system they already had in place. So if you already had a district heating network in place, your local resource consumption and patterns would look different than if you didn't, because the costs would also be affected. So you saw, this interplay between a lot of different factors that emerged through my PhD work at the Paul Scher Institute, where I really took this system level perspective again. So I think that's the recurring theme also in all my work, is how do we look at the problem from a systems point of view and a macroscopic point of view so that we can find better opportunities and solutions and see how things are interacting. So you converge to a solution that would be more holistic in nature.
And I guess it seems more continuous, compared to the experience that I'm sort of picturing. In water, if we think about rainwater or wastewater, we sort of have certain levels at which we can do recycling and harvesting of these kinds of sources. But when you're thinking, again, small hydropower is very related to water as well. So there you're limited to sort of the creek or river system that you can harness the power from. But when you're thinking of other energy sources like wind or solar or some of the examples you mentioned, it feels like the scale of application, the level of decentralization or degree of centralization is always varied, and it's really highly dependent on the demographic composition, on the existing infrastructures, I guess on how dense the community is built as well.
Yeah, absolutely. And when I did my work, I applied what we call the clustering approach. So we tried to, because I couldn't manage to model every single community and it wouldn't be time effective or meaningful to do that. So one thing that I looked at was using clustering methods to identify what are the types of communities we had. So I had a number of what we called archetypes emerge of different archetypes of communities. And so you would get these high level trends, but I wouldn't be able to say that when you got an archetype like Zurich was allotted to archetype 121, for example, I would not be able to say that all of the Zurich type archetypes should have now the same energy system, because what you would need to do is you would get a high level understanding of what's important in these communities. You really get the macroscopic understanding. But in order to actually implement these, you need to do a more detailed study that's very contextualized, taking into account the factors that you mentioned, to give you a really tailored and more effective solution for a specific community or a specific context. But it's still a very valuable exercise to understand from a high level what is important, what is emerging. That also helps to inform national policies of what kind of support do local communities need. And then, it's a different level of analysis.
I mean, I'm picturing parallels in the kind of modeling that I do, the planning support for nature-based solutions and I guess multifunctionality as well, ecosystem services. You need to have that high-level picture. And then you can go into, the local scale effects where you start to see, okay, this district, is maybe facing flooding issues, much like in your discipline, this district is facing energy shortages in winter, for example, or this district is emitting too much CO2. That would factor in quite substantially, I think, in a lot of the modeling and optimization work that you undertook as part of your PhD and thereafter as well.
Yeah, the optimization modeling was really the workhorse of my PhD and also influenced still the work that I'm doing today. And it can definitely give you interesting insights. I mean, optimization models are different than simulation in that optimization models are more prescriptive in nature. You have an objective in mind. You have the end goal in mind of I would like to minimize costs or I would like to minimize CO2 emissions, and this is how I'm going to get there. Whereas simulation models are, I want to see how a system develops once I put it into motion. And I don't know, to understand what the complex interactions might be. And so it's more descriptive in its nature, actually. So I used to work more with simulation models when I was doing the tidal and solar and biogas modeling. But now I work on this prescriptive side of things of how do we plan for that future that we want. We have the goal in mind, and what do we need to do to get there, which presents its own challenges and complexities because you have an idealized pathway to the future, but how you're going to get there and what are the other complex system interactions that I'm not thinking about, which would make it challenging to get there. If it's, we're going to put all heat pumps and renewable energy till 2050, what's the societal interaction? What are the socioeconomic implications? What are the equity issues that might come up? All of these kinds of domains of thinking, which I have never really not deeply explored yet.
They say the more you know, the less you know.
Yes.
At least when you look at the Dunning-Kruger effect, you're confident at the start when you know a topic, but after a while, you start to realize, oh my God, there's all these uncertainties that I have to deal with. And you start to, expose yourself to new areas, much like that fateful conference you attended, which exposed you to a whole range of new ways of thinking. You finished your PhD in 2017 and then continued with Empa, and you continued that modeling, as you said, transitioning more into the optimization space and got to work on a project called Rise of Renewables in Cities.
Yes. So I was working with the International Renewable Energy Agency, and the publication at the end was called The Rise of Renewables in Cities. And the project was really about understanding the breadth of modeling tools that were available. For IRENA, it was important to apply these tools to see how you could integrate renewables and scale up renewables, model renewables in city contexts. And so a big part of that was I did a review study of over 100 tools that are in this field. So there's really a lot of them, and they're kind of a little bit same but different, like they have.
I know that feeling from the water side, exactly. Well, I think we share the same parallels in our disciplines.
Yeah. So then, you know what I mean, that there's sometimes an overkill of tools out there. And my job was to review them to understand what are the stronger tools for the specific context of what IRENA was interested in. And also further to understand what the gaps are in the field. What are the technical challenges, the methodological challenges, the institutional gaps that exist, and what solutions can we think about to help reduce some of those gaps.
And perhaps one of the important aspects is also whether people are even using these tools to help plan energy systems.
Absolutely. And so part of the process was also stakeholder interviews. So talking to urban planners and asking them, these tools exist, is, what's stopping you from using them? And you would understand, for example, that capacity was an issue. So they didn't have the technical capacity to do it or the funding to do it. And so then they would need to rely on external consultants, which gets expensive. So I realized a lot of the challenges that exist there, and it inspired several of my other proposals then after that project, because having an understanding of the gaps and also the real world challenges then inspired my next work, which was in the context of Ghana.
And that is a project I definitely want to get into, because I think that's one of the key highlights of your career so far that has really opened up the doors to this holistic thinking, this systems approach. Yet again, we saw the example in Pakistan, but this one was really then research focused and really changing, the thinking and creating impact in West Africa. It was not your first foray into Global South, but it allowed you to use your prior experience from the Global South into creating change.
Yes, this project we called it the Measures Project, and it was my first attempt, I would say. It took me, prior to this project, my systems thinking was within the engineering domain. And this is the first project where I challenged myself to work with disciplines that I had very limited knowledge about. And so this project overall was about how do we improve our modeling methods, which are often very idealized, in order to account for some of the challenges that exist, the imperfections that we assume are not there, particularly in the context of many Global South countries. Ghana was one of them. So we looked at low and middle income countries in this project, basically was what we had in mind. And we wanted to see how challenges with, for example, in the economics point of view, with unstable currencies, with depreciating currencies, how you plan a long-term project, or also the informal sector. Yeah, that was one of the fields. But basically, it was between economics, climate modelers, power systems engineers, and ourselves on the Swiss side. So the other researchers were based in Ghana.
And your focal city was Accra, the largest city in Ghana, 2.5 million people. And I guess for some stats, because we love our stats, the annual energy consumption there is 3 megawatt hours per capita, which is actually quite small compared to European countries, which are more 30 to 40 megawatt hours per capita, or the US and Canada, which range around 70 to 100 megawatt hours per capita. I'm not the expert with energy units, but I believe this is the way you normally characterize energy usage in countries.
Yeah, and so the energy usage in Ghana compared to a country like Switzerland or Canada is vastly different, and their needs are vastly different. And so, yeah, again, working with local researchers and people who had an understanding of the local context was really important. We also tried to involve the Accra Metropolitan Assembly there so that they were also in touch with the models and could inform our scenario development because, yeah, in the end, we wanted to advance these modeling methods so the models would be more useful. With at the heart of it, resilience in mind, actually climate resilience for cities. That was one of the main goals, is how do we plan for more resilient communities from the energy perspective by considering imperfections, local economic conditions, suppressed energy demand, climate change. So we looked at, changes in precipitation, heat waves, flooding, hydropower influence.
The whole 9 yards.
Yeah, so it was really interdisciplinary, meant to be transdisciplinary in nature.
I mean, just reading about it, it's fascinating. You, on the one hand, relied on, I guess, IPCC, Intergovernmental Panel on Climate Change, for those who are still unfamiliar with the acronym, but you relied on their kind of scenarios that they put forward for future socioeconomic pathways. As far as we know, there's 5 current dominant scenarios of how socioeconomics can develop. And you coupled them with the future climate, so high emissions, low emissions. But then also looking at, I guess, your own on-the-ground scenarios. What do we do? How do we make decisions using the optimization knowledge and experience that you developed?
Yeah, so we used exactly the IPCC SSP, or these shared socioeconomic pathways, as kind of guidance for what type of scenarios we could look at from a resilience point of view. And we took that into the local context. So we also looked at climate migration, for example, into a city like Accra, and the IPCC had very helpful resources for modeling estimations of population densities. So we used that information to look at how energy demand would change in a city like Accra when you have rural-urban migration due to climate change under the different SSP scenarios. How also the heat effects and the informal sector changes as well, because if you have a big influx of people to the city, it can exacerbate also the informal sector if the city is not prepared to absorb it. So these are some of the socioeconomic issues I worked with the economists on.
Interesting. And I guess you have to really picture it. We might be facing, or we're likely to face, more frequent warm days and warm nights in most of these Western African countries in future. And therefore, you need a plan for that, because when it's warm, you'll need the energy to cool unless you have other solutions, which I guess would also factor in. And so how does that then affect where people choose to live, to work and stay, and whether the population then densifies or spreads out as well as a result of it? So many variables at play.
Yeah, a lot of variables at play. And I think we only touched on a handful of them because we were limited in time and capacity. But it's really like this rabbit hole of problems, because once you start thinking about one, it opens up several other doors, which lead to several other doors. So it's a complex system. And that's, I think, one of the biggest challenges is sometimes it's overwhelming to know where to really start to tackle this problem in a meaningful way, because you can come up with a simplified model and some results, but whether or not that's really useful in the end, that's kind of the overarching theme of this project, is how do we make these models more useful when you have these socioeconomic factors that you haven't even considered at all from an engineering technical planning model, which just looks at this is how much it costs and these are the potentials that we have to install them, and not even considering informal settlements or anything.
The famous quote from Box and Draper, all models are wrong, but some are useful, is very much well and alive in especially this context as well. And with systems thinking, I mean, we need to, I think, as the world progresses into the future, becomes more complex and also more AI driven, especially, systems thinking is a skill that we all need to have. It really defines, I guess, our ability as humans to solve problems. But of course, at some point you have to draw the line. Where do you set the system boundaries? And I think that's systems thinking 101. The first class you have is understanding what a system boundary is. But I think these boundaries are becoming more and more fluid as time passes, just because of how many different factors we have to take into account nowadays.
Yeah, I think the deeper you get into understanding a system, the blurrier those boundaries become, because
The rabbit hole, as you say.
Yeah, because before, if it was just an engineering system, I could think of it in terms of here's the mechanical, electrical, computer, components. As a system in robotics, the line was easy to draw. But now if you're going to get into concepts of energy, I was also, in kind of just the thinking of I'm just designing an energy system for a given energy demand. And that's a pretty straightforward thing when you have an optimization model. And what's not straightforward is now when you put it in the context of that in which it exists, the social conditions, the policy conditions, the geopolitical conflicts, the whole world, climate change, people's needs, well-being, planetary boundaries, all of these things. When you look at that, you end up feeling like the boundary is the earth, that's it's difficult.
Well, thankfully it's still the earth, imagine we had to now encompass more planets as well, but I guess we'll leave that to the thinkers of the future. Well, we'll see. Maybe it's still in our lifetime at the rate of human progress. But in relation to the optimization, and you've mentioned multi-criteria decision analysis back in the wind power experience, but here it's about optimization, and I guess from many different angles. One aspect which I found was incredibly elegant, and I've heard this term before, is this concept of regret and minimizing regret. And I've heard this in planning where we try to come up with no regret solutions. But there's often times where you cannot take the best decisions. You can have all these options, but sometimes it's just not feasible because even though it may be the best on a number of different fronts, you're looking at multiple objectives. So there are trade-offs to be made. And this idea of regret is something that I found very fascinating in the work that you did here in Ghana. Tell me a bit about how this concept or how this word factors into optimization and decision-making under uncertainty.
Yeah, so this was a concept that also for me was new. I was having a conversation with a friend of mine who's a professor at TU Delft, and he works in optimization as well, but much more theoretical, mathematical. And he mentioned, we were discussing this regret concept actually one day, and then it occurred to me that actually, as far as I knew, this hasn't really been applied in resilience of energy system planning for cities, and especially not in a context like Ghana. And what regret is about in decision making, it's just the word itself, everybody can relate to it, right? Everybody knows this feeling of regret, but there's a way that we can quantify that mathematically in decision making as well. And regret can be thought of as basically the difference between the decision that you made and if you could apply a cost, literal cost, let's say, that decision that I made between buying something today and when maybe I would have bought it in the future if it was on sale, for example. Yeah. So if I knew in advance it was going to be on sale, of course, I would have bought it for 50% off next week, let's say. But I didn't know that. So I made the best decision I could today. And what I may experience as regret is the difference between the decision I made and the best possible decision that could have been made if I knew everything, if I knew the future. And so if it was 50% off, the regret function would say, okay, it's the difference between I paid $20 today, but I could have paid $10 next week. And so my regret is the difference of those two. It's $10 is my regret in that case. So that's a mathematical way to quantify.
Yeah, and that's working on one factor. So imagine if you paid $20 today, $10 next week, but at least you got the enjoyment for the one whole week extra by paying the extra $10. So that also factors into the whole decision. Do you regret not having it sooner or things like that?
Yeah. That's you have to define this loss function actually also. So that can come into there. So basically, this regret function is a way to quantify that regret. And when we wanted to apply it to the case of planning for resilience. And so basically the overarching question is if you plan for resilience today, would you minimize your regret in the future when a climate disaster hits? And how do we quantify that? Because the way that we kind of plan energy systems is without a lot of resilience thinking, and we kind of adapt as disasters happen, as things go wrong, we adapt. But the idea behind resilience is that you think about them beforehand so that you can minimize regret. And so that's what we looked at in one of these papers, was a series of uncertain scenarios looking at volatile energy supply, volatile possibly fossil fuel markets in the future, hydropower fluctuations, the currency depreciation. And that's also just a small subtopics of many possibilities, but this was one of the last papers in the project, so we had some time to think about all the uncertainties. And so we identified a set that we wanted to look at. How do you plan for an optimal energy system, if you knew this in advance, all of these uncertain futures, how would it influence your decision making today? And so we calculated regret across these different scenarios, and we had something for more robust planning or stochastic planning. Yeah.
And so, I mean, without oversimplifying it too much, the answer or the result of it is something that you would hope to think is obvious in people's minds, but at least you were able to prove quantitatively, and that is that you want to try and minimize your CO2 emissions as early as possible. You want to have diverse technology sets and cross-sectoral flexibility within Accra so that, Accra remains resilient to any future uncertainties.
Yes. And I think by putting numbers on it, it can help convey the message clearer.
Evidence-based.
It's evidence-based, exactly. And also, it's not always because you have so many competing uncertainties and costs and priorities. It can also give you some insight into where you should focus within that realm of uncertainty. And so I think that's what the quantitative analysis is helpful for as well, because it does seem intuitive that you should plan for a more resilient system. But why do we not do it? And it's usually often cost-driven, that it's more expensive to do it. But if you do it from this quantitative evidence-based approach, you'll see that actually it really pays off to plan for resilience.
People often think models are tools that crunch numbers and give you the answers. Actually, no, I think models are often there to enforce the gut feelings and answers that you may already have of what the right way might be, I feel. And this seems to be a classic example of that, where, yes, it's a complex situation, but with enough deliberation and discussion, you often can come up with a solution. But how do you create convincing evidence for that and actually show people on the economic balance sheet that it actually works out? And that's where the models can really show their true power.
Yeah, absolutely. I was having a discussion actually with someone at UN Habitat about this exactly, because they work on urban planning aspects, and we were seeing how we could work together also maybe on urban energy. And one of the things they brought up was that we want this evidence-based approach to help us really make it happen on the ground, because that can be very helpful in that dialogue.
That's fascinating. And so I guess since a lot of these research papers have come out for the project, how have things been on the ground with Accra? How have the results been received?
A key part of this project was I was the only Swiss researcher really working on it. And then the rest of the team with 3 other research teams also at different universities. So we were working with KNUST and the University of Energy and Natural Resources. The idea was that we have the local knowledge, we learn from them, and also with the modeling methods, we can hopefully bring in some knowledge as well. We worked with the AMA, the Accra municipality, and the idea was to make it as inclusive as we could to get all these stakeholders on board. So the design of the scenarios and the uncertainties that we looked at was in collaboration with the local experts. And so I hope that it would be used in the future. I think it's also challenging with the city level, for example, because they didn't know the models. This is this problem that we also saw with the IRENA feedback, that the capacity is not there. So although they would like to, it could be challenging. However, this dialogue is still ongoing, because I've also connected with Climate Compatible Growth in the UK, who are also working in the context of Ghana. And so we're still have a master's thesis student working on hopefully the topic of 15-minute cities in Accra and how you can redesign a city. So we're hoping that the models that we've created also, they'll still be useful both in academia and hopefully on the ground as well, because that's really the idea, is for it to be an applied, useful model and research project.
Mashael, we've come full circle, because shortly after the Measures project concluded, it was when you attended that fateful conference that changed or introduced you to these key concepts, especially the concept of sufficiency. So where you're at now, looking back on everything that we've covered so far.
Yeah, actually, talking about it is interesting, because it also makes me see the patterns in what my thinking has been as a systems thinker, how it's evolved, how it is evolving, how it will evolve. I would be very curious if you had interviewed me 5 years ago, I would have given you totally different perspectives, I think.
Interesting.
Than today. And 5 years from now, I'm sure that'll also be, maybe a year from now, that'll be different. I don't know. I see that as very important, actually, in my growth as a researcher, as a thinker, is to constantly evolve. And I'm sure that some of the ideas that I have today, I'll challenge those myself going down the road. I don't know exactly how it'll look, but I'm very excited about it. I think at this point in my career, that now I'm at Empa as a group leader, that I can try to build this vision around this, looking a little bit outside of the technocratic domain, and how do we approach the problem in a more holistic way. And sufficiency is part of that thinking. It's also that opening to this world has also gotten me involved with the World Sufficiency Lab, where I'm there as a scientific committee member, and also with curriculum as well. So seeing where the gaps are, I can look back and I see where the gaps are in my education as an engineer, as a ETH graduate as well. But I did my master's and my PhD with ETH, and yet sufficiency was not something we never discussed it. And I think that I realized that there's a gap in how we're training engineers as thinkers as well. And that's something I also want to work on. So there's so many different ideas now I'm working on in education, in working with these think tanks, or what the World Sufficiency Lab calls it itself a think to do tank.
A think to do tank.
Yeah,
okay.
because they really want to be applied.
Yeah.
So my world is opening up, and it's exciting and it's intimidating as well, because it's a lot of areas that I am new to, that I'm green to, and I'm learning from people. And that's part of the process.
One quote that you mentioned to me as we were preparing for this episode comes from Alvin Toffler. And the quote says, "The illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn." That seems to embody a lot of, I guess, the thoughts you're having now with curriculum, with the way your systems thinking has evolved, or just your general thinking has evolved.
Absolutely. So this was a quote I came across just a few weeks ago when I shared it with you, that it really hit home, because I think that's also very important for all of us to do, whoever's has an interest in thinking, or being, that it's very important for us to be able to learn things in the first place, but also to be able to unlearn them if we're open to seeing the potential errors in our ways of thinking, our biases, our arrogance also in academia sometimes. To be able to unlearn, to be willing to unlearn, and then relearn, and who you relearn from and how you relearn. And that really requires a humility as well in thinking, in the thought process, is being able to admit that you have not been seeing things totally the right way, and where can you do better. And so that's also what inspired what I'm trying to do now with curriculum changes, is introduce courses to make, particularly because I know engineering, as a domain, and I know what's been wrong with my own education. That's something that as an educator, I would like to course correct in the future, is how we can help students to think about the energy problem, for example, in a more macroscopic way, and how to think about it critically, and how to do this process of unlearning and relearning in this domain as well, or hopefully learning. So if they're, students are young enough, they haven't yet been set in their ways. And so to try to do better in the first place from the course point of view, and also as a society. So with the World Sufficiency Lab, they have national hubs. And so I'm trying to create at the moment a Swiss national lab for sufficiency, and we would call it the Swiss Sufficiency Lab. And that's also trying to, as a society, one of the aims is, how do we talk about the concept of sufficiency? How do we normalize the discussion and not make it a scary word, which means that I have to take cold showers and be miserable and not live my life of luxury? How do we bring the dialogue to society to bring in these different daily practices and measures and policies to reduce our base demand for energy and for resources in the first place, while maintaining well-being and planetary boundaries? So with the Swiss Sufficiency Lab, the idea would be that we mainstream this kind of dialogue. And we also, as a society, what we want to do is see how we can learn, unlearn, and relearn. And that's very important for us to be able to tackle the entire climate crisis. Because what we're doing right now, most people would agree, is not working globally. The trajectories that we're on, the inequalities that we see, the pathways we're on is currently 4 degrees, according to the UNEP emissions gap report. So that is really concerning, and it tells us something is off. And rather than be stubborn about that, what we're doing right now is working or will eventually work. We have to challenge ourselves to unlearn and relearn, actually. So this stems from not just the university level, but us as an entire society, on how we go about tackling the climate crisis we find ourselves within.
And it's a double difficulty task, because on the one hand, we need to tailor ourselves to long-term thinking and not short-term gains, which sometimes patience becomes the excuse for, not unlearning. And then on the other hand, we need to be able to, see when it's time to pivot, unlearn, relearn, as you said, and then have the long-term patience and long-term thinking in place. So I couldn't find a perfect solution for that, but I certainly know it's a very big challenge.
Yeah. I mean, the The climate crisis itself is one of the biggest challenges we faced as humanity, if not potentially the biggest challenge we're facing right now. And it's one of these, so-called wicked problems because it's so complex. And that actually also brings me to the thought of how important it is for us to spend a very long time understanding the problem before we jump to solutions. And this is something I also, as an educator, I try to bring to my students or teach them, is how important it is that you spend way longer than you think you need to understand a problem, particularly if it's a problem like a climate crisis, before you decide that you know the solution. Otherwise, you end up with solutions that are ineffective, or in the worst case are exacerbating the problem. Best case, maybe they help a little by chance, but only by chance because you didn't understand the problem fully. And that actually reminds me of a quote from Einstein, which says, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about solutions. And so maybe for the rest of us, I don't know, we'd make that 50 minutes and 10 minutes if we're not Einstein. But
still very reasonable.
Yes, exactly. The point being that we must spend a lot of time understanding the problem. And I think that that's one of the areas I see where we've gone wrong is we have an arrogance about thinking we do understand the problem, but it is so deeply complex and it involves so many things that if we try to put Band-Aid solutions on it or purely technology solutions on it, we won't end up at a truly solution that we need from there.
It draws a lot of parallels to a similar discussion that we've had on the show before, where you can't solve problems by putting a Band-Aid on a bullet hole, said by Shabar Ali back in episode 25. But very true. I think once we understand the problem, and from, I guess, many different perspectives as well, we are in a much better position to propose solutions. And oftentimes half the ideas for solutions will fall away as well, because we know that they're not adaptive, they're not optimal, and they're not useful.
Yeah.
So I guess looking back at all this and now looking into the future, where you're heading next, you brought in the NBS. That's how we met as well. Is that going to be part of the storyline now as well?
Yeah, I hope so. I mean, I'm open as much as possible. I try to remain objective in my thinking. And so even if there's an idea I'm excited about now, it doesn't mean I'm going to cling on to it forever. And so I think that's really important in being able to evolve as a thinker. There's kind of 3 key pillars to my research vision at the moment. One of those is moving beyond this purely technocratic solution space where I've spent a lot of my career. And it's not to say that that's not a value or that people shouldn't do it. It's absolutely needed because at the end, we need to do things the right way, but we also need to do the right things. And so that's where I'm thinking right now. So moving beyond the technocratic space to include complementary novel urban planning concepts, which includes nature-based solutions in urban environments, 15-minute cities, mixed-use development strategies to reduce our energy demand, things like policy and regulation innovation. So that also with nature-based solutions is how can you modify building standards to bring these things in. We also need to discuss economic and social reform. Where are our priorities right now? Is well-being really at the forefront of what we're doing? Our societies are largely driven by economic indicators, these efficiency ratios. With GDP, for example, and GDP is not a measure of well-being, as many studies show. Not. And so there's something called post-growth thinking, systems thinking as well, which is measuring what matters. And so what matters is not really GDP, it's well-being. And so how do we reframe it there? So that's the first kind of pillar, is moving beyond this technocratic solution space. The second, as I've touched on as well, is exploring multi-system interactions and co-benefits in order to enhance the effectiveness of solutions. And that's where we can really develop solutions that have symbiotic relationships with multiple systems, as we discussed before. And that, in the end, it's valuable because it lowers also implementation barriers. It increases acceptance. It amplifies effectiveness. So these types of solutions, I think, are really important for us to focus on, and includes nature-based solutions or energy sufficiency, post-growth thinking. All of these kind of concepts fall in there. And the third one is about reframing our thinking and the energy transition, what its objectives are and how we analyze it. And so as an energy system modeler, what I'm trying to also shape my models towards is coupling this with ideas that are outside of the traditional energy modeling domain. So linking it with the Doughnut economy, for example, as a framework, how do we link energy models actually? Because at the heart of it, our relationship with energy is what has brought us into this climate crisis, is exacerbating it, is the cause of it. Everything is driven by our relationship with pulling fossil fuels out of the ground and using them, and how our entire societies have developed as a result of that. And so, we need to re-examine what our transition looks like and how we go about analyzing it, and linking then these energy models more explicitly with planetary boundaries, with well-being measures, with something called these need satisfiers framework, where basically we have needs and we have ways to satisfy the needs. And an example of a need would be, as a human being, that you have subsistence needs, you have needs for comfort, for leisure. And when we talk about leisure, a simple example of needs and satisfiers is I could satisfy my need for leisure by taking a hike in the mountains in my backyard. There's some nice hills. I could do that.
Or getting to the nearest park within 15 minutes. Bring in 15-minute city
exactly.
concept.
Yeah. Or as some people would associate leisure as I go on holiday to an island, I don't know, in the Maldives,
Yeah.
And so both satisfy leisure, but in very different environmental footprint ways.
True.
And so you can meet a human need in different ways as satisfying that need. And so bringing this thinking in as well into the energy systems modeling and planning point of view of how do we reduce the stress on the system, and reframing our goals really as less of a transition and more of a metamorphosis as a society, actually. So it's not as simple as just moving from fossil fuels to renewables, but it's much more than that.
And I look forward to seeing how the transition unfolds itself, especially in the nature-based solution space, but also, how we define leisure and how we quantify that, because that's certainly very intriguing too. But Mashael, this has been a very wide-ranging and deep conversation about a lot of interesting topics that have certainly taught me a lot of new things about energy that I didn't really know before. And some of the things I've only understood superficially. But like I do with every guest, I'd love to get into a few questions so that listeners can get to know even more about you. And so innovation is a word that surprisingly, I don't know if it popped up in our discussion, but to you, what does that word truly mean? And how has it shaped the way you approach challenges, opportunities in your work?
I think innovation for me is really about being able to look at a problem with a fresh and new perspective, and to see what people have not seen there before. And it's also to not be afraid to do so, actually, because it requires a little bit of this unlearning and deconstructing our understanding of a problem. To not be afraid to leave one's comfort zone, and to be able to break down your assumptions and challenge your assumptions. And in the process of doing this, I think the space for innovation opens up, where the spaces between is then where your creativity and that innovative spirit can bloom and thrive. And so for me, that's what innovation is about thinking of a problem in a new way. It also brings to mind a quote that I also liked from William Faulkner. And he said that you cannot swim for new horizons until you have courage to lose sight of the shore.
Oh, wow. Yeah, that is visual and that is powerful. I like it. So what tips and strategies can you offer in terms of time management? How do you maintain a balance between your professional and personal time?
Yeah, that's a good question. Just on this weekend, I had spent my first time trying a silent meditation retreat. It was a day of meditation. I had organized for our lab a mindfulness-based stress reduction course, which some of us were then doing together over 8 weeks. And so this was the culmination of that. And that was a really interesting experience, a new experience for me. And more, I'm finding that meditation is something that I use to help me manage all my time.
Interesting.
And also that it becomes sometimes, we really distinguish between personal time and work time. And for me, it's becoming more of a blur, because the things that I care about, I'm happy to think about them in my personal time, because they're moving for me, or they give me that depth. And I think I'm very lucky to be able to do that. But for me, meditation, I think, is one of the key pathways I'm cultivating in myself to give me perspective, because I think that's what meditation really does for many of us, is it helps give us perspective and maintain perspective. And so when you can have that perspective, you free your mind and its resources, which helps me then to manage my time better. I can live more fully in whatever, if I have a stressful work day or I have a fun weekend day, I live each moment more fully. And it's more satisfying, even if it's a stressful work day. And I'm less in this mode of, I used to, and many of us maybe can relate to this, is that you kind of wait for the weekend to come. You get through the work week to get to the weekend. And I find myself doing that less and less when I meditate, because I can modularize them and I can live more fully. And when I have that perspective, I think it helps me, it frees up resources mentally. That allows me then just to be a better version of myself. So I find myself being a better colleague, a better partner, a better family member, a better daughter, a better sister, a better friend, and a better stranger even. So I find that it allows me to open space for others, which is also really important to me in this perception of how fully I can live my life. I find myself having the capacity to think deeper thoughts, to have better focus, to have more empathy for others, and that time slows down. So that time slows down kind of feeling is where I can enjoy the time I have, whether it's an interview like this or it's Saturday and I'm going to go hang out with my friends. I enjoy each moment more fully. So I think that would be if it's something one is curious about, can be very helpful in managing personal and professional time and drawing the line and knowing what's important.
Fascinating. Yeah, I definitely try to make meditation part of my daily ritual as well. Any tips for those who want to start out?
Oh, yeah, there's a lot of possibilities. I mean, I'm no meditation expert, but my curiosity was first piqued by an article I had seen from Harvard, which was called 8 Weeks to a Better Brain.
8 weeks to a better brain, okay.
And basically they had taken non-meditators and put them in an 8-week mindfulness-based stress reduction or MBSR course and had seen how not only do they report feelings of well-being, but also their brain patterns had changed and it was measurable. And I found this really piqued my curiosity. And at the time I was a PhD student who was stressed and was just curious. I was just an open curiosity, like, could I do one of these? I couldn't afford to do a course myself. So I had found a free online course that I could do at my own pace. And that was a game changer for me, actually. And that's something anybody can do. So there was a free MBSR course, which is still available, called Palouse Mindfulness.
Okay.
I can share the link with you after.
We'll put that in the show notes, definitely.
And that was, for me, very transformative because it's something super simple. As one of our meditation teachers said, it's simple, but it's not always easy.
True.
But it's a simple concept, and there's a lot of interesting resources there where you can learn about how meditation affects, also from a scientific point of view, for those of us who are more inclined, as researchers, it's more convincing to reach us that way, to see how, for example, gray matter in our brains, as our brains age, gray matter decreases, but in long-term meditators actually stays the same. So there's several articles there that are, to me, exciting, pique my curiosity, and then the practices are really simple. So if you had anything between 10 minutes to half an hour in a day where you could dedicate to that practice, you could see how it would feel with you and sit with you. And if you have a further curiosity, you can do the full 8-week course right now, on for free by yourself. So so that's a good starting point.
Listeners, check it out. In the show notes, with an open mind, we'll put in as many resources as we need to help you get started. What is your favorite childhood memory?
For me, I have very fond memories growing up actually in Saudi Arabia. I grew up in Riyadh and we lived on a compound. And for me, some of my best childhood memories are playing with friends there. So I was very active and I was always loved being around my friends. So swimming, biking, playing tag in the neighborhood, like just being a kid, playing video games. I think I'm a big video gamer still, and it started there actually. Okay. One of my friends had a Super Nintendo and we played Donkey Kong Country on that, and that changed my my entire gaming world, and so I really loved that and still play that game because I enjoyed it so much. So that was really, I think, one of the fondest childhood periods for me.
Video games shaped, I think, what my career looks like now. So
exactly.
We should do a segment on video games one day on the podcast.
I would love to.
What was one of the most challenging situations that you have ever faced in your career to date, and how did you overcome it?
I think that this is a challenge that I don't even know if I've overcome, to be honest, because I encounter it over and over, is working outside of my own discipline and working with other stakeholders and working with people who think in a totally different way. They've been trained in a totally different way. They have different expertise than I. And the language barriers that come with that can make it really challenging. And so in the Ghana project, working with economists and climate scientists and power systems engineer. I mean, there was such a diversity in the way that we thought about the problem or understood the problem that was a significant challenge, actually. And one of the things I've learned maybe over time to deal with that is to plan for more space for that language connection to emerge. So it's not something I had put into the plan, is that we just need some time to understand one another. And that's something going forward I would plan for more proactively, is because it takes time to understand each other's fields and thinking and misunderstandings largely, to not be afraid to ask stupid questions, especially in a context like this. There's no such thing as stupid questions. And I would constantly ask, probably would appear to be simple questions or stupid questions to the economists, but they're super patient and helpful and, help me understand things that I was not trained in. So I think, not being afraid to ask questions is really important for growth, and giving space for this interdisciplinary collaboration were important.
And patience, I guess, being key to that.
Yes, yes. And maybe just the thought there also, the coming to it from meditation, they tell you to approach things with a beginner's mind.
Yeah.
And that's actually really important when you are working in an interdisciplinary environment or transdisciplinary collaboration, to really
not
use
to assume
this beginner.
things.
Yeah, don't assume things. Like, you just come into it like you're totally an empty cup, looking to learn and to be filled. Because if you don't come into it with that attitude, if you already think you understand, you're not going to help yourself in learning, and you probably have to do some unlearning and relearning, in that process.
You got to empty the cup first, and then fill it again.
Yeah, so that I think is really important as a strategy, as a personal approach, is try to come to it with a beginner's mind.
Yeah, we've had so many little nuggets of wisdom and advice that you've offered throughout this whole episode so far, but what other advice can you offer to young scientists starting out, especially in the energy field?
I would say that I think that one of the most important things a young person can do, any person actually, but particularly young people, is to cultivate in you a sense of humility. I think that I have a working theory that's also evolved over time about this question of what is the most important human characteristic to have. And I used to think that it was compassion. But I've come to realize that a prerequisite actually for being compassionate is humility. So I've come to believe, at least in this point in my life, that humility is one of the most essential human characteristics to have. And I came to realize this also through an admiration of people that I admired as thinkers. Not just, people that I admire who would be big names. Noam Chomsky, for example, is one thinker I really admire. When you think of also Einstein, I mentioned a couple of quotes. There are people who exhibit, the one commonality they have is that they exhibit a great sense of humility in thinking. And I think that's what enables them to be great thinkers, actually. So whether that's a Noam Chomsky or an Einstein, in my own circles, if they're spiritual teachers, if they're family, if they're friends, if they're colleagues, that the people who are the most humble, I find I learn the most from, actually. So I think the humility is essential for gaining this perspective, and that enables growth in all aspects of being human. So it's essential for your personal growth, but to have this perspective and be open to your weaknesses in the ways of your thinking so you can learn from them or do that process of the unlearning and relearning, and professionally as well. So as a colleague, as a thinker, as a researcher, as a collaborator, that sense of humility, I think, is, if you can cultivate that, you can be better at what you do. And so that, from both then the personal and the professional perspective. From the personal perspective, can help you to be a better partner, a better friend, a better family member, a better stranger again, that cultivating the sense of humility really enables that growth. And there is one other quote from Einstein again in that direction, which I would give as a piece of advice to young people as well, when he says, strive not to be of success, but rather to be of value. And so cultivating your sense of humility and combining that with the striving to be a person of value to those around you is, I think, what I would advise any person, young people especially, to focus on, and everything else will fall into place as you move forward.
Very golden advice that I think not just young people, but everyone can adopt a little bit more humility in our lives, in ourselves. Because I think in an age where the world is rapidly changing and the future's highly uncertain, our ability to adapt, to learn, I think also depends on us putting our egos aside and being able to admit that we may not know the things correctly, we may not know everything, we certainly don't know everything, but that, we are willing to learn from each other and to also be open to completely different ways of thinking.
And I did want to just mention on the idea of the metamorphosis of our society, that this is not really, I don't see it as an option, this metamorphosis. It will come whether we want it to or not, because we've pushed our planet to its limits and because it can't sustain the kind of societal demands we've created. that metamorphosis will either be forced upon us, and that could be after all is said and done and after there's a tremendous amount of suffering of all life on Earth, or we can choose to do it proactively on our own terms to create a better society for everybody and not destroy our planet. And that again requires humility, because it requires a recognition of what we are doing, where we are at right now, what priorities we've set, whether it's spoken or unspoken, they're evident in themselves. And that we need to rethink our societies at a very fundamental level in order to have this metamorphosis on our own terms and not have them be imposed upon us by Mother Nature. So it's, it's prudent and it's wise and in our own interest to do so.
And so, Mashael, what would you most like to be remembered for?
I guess in that direction, I would like to be remembered as a person who overall gave back more than they took from this world. In both my personal relationships, whether that's as a partner, a daughter, a sister, a friend, an aunt, or professionally as a colleague and a collaborator and a researcher.
And a stranger.
Yeah. That, my life's work that I would like to ideally, and that's not easy to think because I take a lot from learning from the world around me, but to give back something that would be in some added value to society, to be a person of value. That's what I would most want to be, I think, overall remembered for, and to make sure that I don't squander the privilege and the opportunities and the capabilities that I've been given. I want to use the platform that I have access to, including such a wonderful platform as this, actually, to use my voice to spread good in the world and to uplift and amplify the voices of those who feel unheard or who are unheard and who feel drowned out, to do that, because I'm incredibly privileged just by sheer luck to be born in the right place at the right time with the right parents and everything, and to not let that go unappreciated also from my side. Yeah, so I think that's really important to me. I'm a big Tolkien fan as well, a Lord of the Rings fan. And there was one very nice from Gandalf, I think he says this. And he says, "It is not our part to master all the tides of the world, but to do what is in us for the succor of the years wherein we are set, uprooting the evil in the fields that we know, so that those who live after may have clean earth to till." And I like this quote a lot because that speaks to my goal of leaving the fields that I come in contact with, because I can't access the whole world. I can't take on the whole world, but through the fields that I can till, I want to leave them in better shape than I found them. So whether those fields are my work or my research field, or human connection in my community. So that's, I think, where I would,
Beautiful wisdom from Gandalf.
Yeah.
I need to revisit my Gandalf quotes. I only know one of them, and that's the most famous one. You shall not pass. But in this case, I must definitely go revisit that. Where can people find you if they want to get in touch?
Oh, so I don't really have a personal webpage, probably something I should work on. But on our Empa homepage, you'll find me. So that's, I think, empa.ch/web/YAM for my initials. And otherwise, I'm also on LinkedIn. So you can also reach me there. Yeah.
And we'll definitely put links to that in the show notes, as well as every other thing we've discussed today, which is going to be a very nice collection of resources. But Mashael, it's been absolutely fascinating listening to your story and just going along for a laugh and really looking at how we really are facing a change in mindset and how we can adopt the change in mindset, which has certainly enlightened me a lot today as well. But as we wrap up, I always give my guests the final word. So one last message for the listeners to take away from today.
So one thing that I wanted to just add on was an experience I had when I was at COP29 in Azerbaijan last year, where I was in a session where it was an aptly named side event where they were talking about equality and how to overcome this. And I had an opportunity to ask a question to, I think he was at Oxfam. And he was a very good speaker and said a lot of points that resonated with me. So I thought to venture out and ask him this question, because in these moments of hopelessness, this feeling of feeling overwhelmed by how big the problem is and how difficult it is to overcome these structures of power, this concentration of wealth, and how do we as individuals do something about that? And so I asked him, is there a way, or how can we go about it? And what he responded to me, which really stuck with me, was that he said, we can't lose our faith in our imagination, in our ability to tackle these issues and think about them in new ways to create a better world. And he said, I know that that's not much of an answer in that I don't have a clear answer for you, but that's something that is very powerful and has been at the heart of how we've overcome seemingly unsurmountable problems in the past, whether that was women's rights or slavery or other challenges that we've faced, that we can imagine a better world and we can't lose faith in that. And I think that also, when we bring it back to this climate crisis, Yamina Saheb, who I still work with now, who often says that this is not a transition that we're facing, actually. It's not a transition or energy transition or transformation. Rather, what it requires is we need a metamorphosis of our society. And that's not an easy task. It's a task that requires a tremendous amount of imagination, a tremendous amount of hope and courage, actually. And so that metamorphosis will only happen fueled by our faith in our imagination and our ability to do that. So I think that that's something very important that I took away from there and that I'd like to leave as kind of last words if they resonate with somebody else. Yeah.
Thank you very much.
You're very welcome.
And that wraps up our insightful, eye-opening and energizing episode with Mashael Yazdanie. For more information on shopping for your next energy system, some world records around race cars, or useful meditation and mindfulness resources, check out the show notes for more information over at peterandbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you are enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even fellow gamers. Subscribe or follow this podcast on Spotify, Apple Music, other podcast channels, or follow the LinkedIn group to stay up to date with the latest releases. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel Peter Marcus Bach, that's Marcus with a C, or follow me on X at petermbach or Instagram at petermbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.